Here's a pot of hot water. If you leave it in a cold room, it will slowly warm up the space. If you set up an electric fan to blow across the hot water, the heat disperses even faster. Congratulations, you've just discovered a way to heat your room. But if you want constant heating, you'd have to keep replacing the hot water again and again, which is obviously very inconvenient. So you come up with a smarter idea. You build a closed copper pipe system that connects the indoors and outdoors. Outside, you install a compressor on the copper piping, and you replace the hot water with a more efficient working medium, refrigerant. When the system starts, low temperature Freon gas is sucked into the compressor and is violently compressed. Inside the compressor is a pair of scrolls. One scroll is fixed, the other rotates. As the moving scroll turns, it squeezes the Freon into smaller and smaller spaces. The pressure climbs higher and higher, and as the gas is compressed, its molecules move more intensely, so the temperature shoots up as well. This high temperature, high pressure Freon gas then flows back indoors through the piping and passes through a coil. At this point, the Freon is much hotter than the indoor air, so the large temperature difference causes it to release heat into the room. If you add a fan to blow across this coil, you can speed up the heat exchange even more, and your room warms up faster. After giving off its heat, the hot, high-pressure Freon gas condenses into a warm, high-pressure liquid and flows back outside through the pipes. But liquid can't be directly compressed by the compressor, so you add another clever component to the outdoor copper line, an expansion valve. When the high-pressure liquid Freon squeezes through the tiny passage inside the expansion valve, its pressure suddenly plummets. Part of the liquid instantly evaporates, turning into a low-temperature, low-pressure mixture of liquid and gas. This evaporation process absorbs a lot of heat from the surroundings, making the copper tubes and their fins become very cold. The now low-temperature, low-pressure Freon gas, having absorbed environmental heat, is then drawn back into the compressor, compressed again, and the whole cycle repeats. In this way, the system continuously pumps heat from outside and moves it into your room, providing efficient heating. If you package this whole setup into two compact units, one placed indoors and one outdoors, then congratulations, you've just invented a heat pump air conditioner.